Okay, so we're up to the volume of pyramids and cones. Much like the volume of prisms, volume's generally a lot easier than surface area. So we don't even have to look at surface area of cones in this unit. We did do the pyramids. They were probably the hardest thing that we had to find the surface area for, but finding the volume is actually quite simple. And the formula just given there, which is also on your formula sheet, is the volume equals a third of the area of whatever the base is, times by the height of the pyramid or the cone. So really quite simple. We just need to find the area of the base and multiply it by its height, and we're done. Plus multiplying it by a third, obviously. So in this particular first example, we've got a cone given. So the base of a cone is a circle, so the area of that base is going to be using pi r squared. And in this case, the radius is 6, not 12, because the what's given there is diameter, and obviously we need the radius to work out the area. So we plug all this into a calculator, and we got pi times 6 squared, and that gives us 113.097 ... Now, probably good practice to get into is just leave numbers in your calculator, use that answer key or whatever you need to use, or a memory, and round at the end, and that way you're less likely to make little errors. So once we know that, we can go the volume equals 1/3 of the area of the base times the height. That's our formula. So that's 1/3 times by that 113.097 ... times by the height, which in this case is 10. So we kick all that in the calculator. As I said, I've still got that number in the calculator, so I can just press multiplied by, and I'm going to multiply it by a third. I can do this in a different order when it's all multiplication, not all the time, but when it's all multiplication, it doesn't matter what order you do it in. So we got 376.99, that's close enough to 377 millimeters cubed, and that's to the nearest millimeter cubed. Something like that. Okay, so for the next one we've got here, we've got a rectangular pyramid. This is even easier because finding the area of a rectangle is a lot more simple. I just have to pause because I think one of my kids is going to bed. Just one second. So continuing on, we just need to find the area of that base. Probably pretty easy for you to work out, but the area is the length times the width. That's going to be 5 times 4, and that's going to be 20 centimeters squared. There's another one of my children again, so I'm going to have to pause. Just one second. Right, that's all Chiver's children tucked into bed, so we should be right to continue. So what we had there was the area of our base. Of course, we want to find the volume. We use that formula, a third of the area of the base times the height. So that's a third times 20 was the area of the base, and the height is 9. For those of you that are savvy, you'll see that a third of 9 is just 3, and 3 times 20 is going to be 60, and it's in centimeters, so that's centimeters cubed. If you need to use your calculator there, that is fine. Okay, so the next question gets a little bit more tricky, and we've got to find the volume of this truncated pyramid if its original height was 12 centimeters. So the easiest way to do this is to find the volume of the pyramid that was there and take away the bit that's been cut off the top, because of course the bit that's been cut off the top is the shape of a pyramid as well. Because otherwise this isn't a shape we're used to. It's not a prism, it's not a pyramid, there's no real formula for what's been left over. So what we might do is work with this idea that the volume equals the volume, not the area, sorry, equals the volume of the big pyramid, take away the volume of the cut off bit. Something like that. But let's first work out what the volume of the big pyramid would have been. Well, that would have been a third times the area times the height. Now the area of the base of this one is going to be 4 squared, because that's a square down the bottom there, and the height originally was 12. So that's what the height of the original pyramid would have been. A third of 12 is that's 4. So what we've actually got is 4 squared, which is 16 times by 4. So that's going to be 64, but you can use your calculator there. And the volume of the cut off bit, well, that's going to be once again, that same formula, a third of the area of the base times the height. The base of the cutoff piece is actually what is the top here. So these dimensions here, this 2 by 2, would be the base of what would be the top of that pyramid. So what we've actually got is a third times by 2 squared, because it's a square once again. And the height, well, if it was originally 12 and there's 6 left, then there must be 6 here. You know, what was missing must have been 6 high as well. So a third of 6, well, that's just 2. 2 squared is 4. 4 times by 2 is 8, but you can use your calculator. So the volume, therefore, must equal 64 minus 8, which is going to be 56. Better put our units in. What does it say? Centimetres, so we're in centimetres cubed. Okay, so it's kind of a composite solid there. The next question is one from 2015's general maths paper. So the Louvre pyramid in Paris is a square base with side lengths of 35 metres and a perpendicular height of 22. What's the volume of the pyramid? So we just need to use that formula. Volume equals 1/3 area of base times the height. Obviously that's going to be 1/3 times by, if it's a square pyramid, we're going to have 35 squared is the area of the base. And the height of the pyramid is 22. We just simply pick up our calculator and plug all that in. So we've got 1/3 times by 35 squared times by the height, which is 22. So that leaves us with an ugly fraction there, which we'll press that button and we get 8983.3 repeater. 8983.33 blah 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 blah. And if we look there, there's a nice little answer there given for us. Okay, so nice and simple to do, not quite a hard question. The next question now asks us to use a bit of algebra to do something similar. Don't get too hung up on the fact that it's algebra, just use your formula. So your formula is the volume is a third of the area of the base times the height. Well, the area of the base, that's just a rectangle, so we just multiply everything together. So that's going to be 4x times by 3x, and then times by the height. The height in this case is 2x. Now remember, when we multiply with algebra, we can just multiply all our numbers first, and then we can multiply all of our letters. Now, a third times by 3, those two numbers, I've lost my highlighter, there we go. These two numbers here are going to cancel each other out. A third of 3 is just 1. So the other two numbers left is going to be 4 and 2. 4 times 2 is 8. X times x times x is not 3x, it's x cubed. So we jump up here and we see, there we go, there's an answer right there. Okay, so have a crack at those ones, the questions in the text, and I will see you guys on Wednesday.